Hello, welcome back. This is Kaylee. We're going to talking about logic still, building up to the idea of truth tables, and then talking about logical equivalence. We're going to do this truth table. We're going to complete a truth table for this compound proposition. And you should have an idea of what a truth table is and how exactly to go about building that truth table. There's a couple of videos back you were introduced to that. So the first thing that we need to know going into this truth table is just kind of the general structure of it. We need to know how many columns do I need, how many rows do I need, to kind of get a strategy going here. And so to think about that, let's go back a slide here. We're going to need a row for every possible combination of truth values for our atomic propositions. So what that means is if we look at this compound proposition, we have three atomic propositions. We have P, and we have Q, and we have R. We use these propositions to build our compound proposition. So for sure, the first three columns are going to be P, Q, and R. And then our rows are going to be listing the truth value combinations. So I want you to take a moment and think about how many truth value combinations are there possible? For P, I know P can either be true or false because it's a proposition, so it's either going to be true or false. I know Q is either going to be true or false because it's a proposition and it must either be true or false. R also is going to be true or false. So go ahead and try listing them. I could have true, 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 right? That's one possibility. Right? You could build a little tree for this if you wanted. True, true, false, 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 true, 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 false, 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 true. What do we have? 2, 4, 5. False, true, false. See, this isn't a very good way to go about it because you lose track. False, true, 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 false, true, true, false, true. Do we have that one? Okay. So hopefully you came up with these 8 too. But this is gross, right? We don't want our rows to look like that when we're building a truth table with 3 compound propositions. So what you're going to do, there's a nice order that I always remember, and then that way I don't ever forget those 8 and I don't have to do what I just did and think about all those truth value combinations. The way to remember it is 4 truths. So I remember 4, 2, and 1. So I go 4 truths, 4 falses, and then 2 is my next number, so I go true, true, false, false, true, true, false, false, and then 1. So I think when I do this 4, 2, 1. That way I hit all of them. It's just a way to remember how to list all these truth value combinations. Alright, so now if you notice I have 8 rows, meaning 8 possible truth value combinations. So what a truth table is trying to do is say, if I choose any truth value for P, Q, and R, what's the output of this overall truth, overall compound statement going to be? And so in order to get to this final compound proposition, we have to understand how to break it down. It's sort of like we've got 5 times 4 minus -2. So in order to evaluate this arithmetic, we have to think about order of operations. And the same is true in the case of logic. We have an order of operations that we have to follow. And the order of precedence, let me go back and give you a peek here. Order of precedence, and just like with arithmetic, you're always going to do parentheses first. You're going to evaluate anything in parentheses. So that would be your first column if you had something in parentheses. And we'll see more examples of that here. But you're going to start with negation. Negation. And then you're going to do ands and ors from left to right. And paying attention to parentheses, right? Because we'll see there's some funny things that happen with the order of these ands and ors, okay? So be careful and pay attention to those parentheses. And then we'll do our implications. And remember, a biconditional is just two implications put together, but we will evaluate those last. So keeping that in mind, I could have put parentheses here to indicate that we need to do the P or Q first. But actually, I don't need them because of order of operations, order of precedence of these logical operators. I know that I'm going to evaluate P or Q first. So what we're doing is just breaking down this final compound proposition that we want to go to. So first, I'm going to figure out the truth values of P or Q. Also, notice in my order of precedence, the negation symbol comes before this implication. So I know I need to evaluate the negation of R before I put together the implication. So, and then my last step, I've got my hypothesis and my conclusion here. Last step is just to combine those with implication. So I'm going to figure out the truth values of P or Q. I'm going to figure out the truth values of negation of R. And then I'm going to put those truth values together with an implication. So you've got a lot to look at it here. So it's nice to have it on a piece of paper and kind of block out the columns that you don't want to pay attention to. So when I'm trying to evaluate P or Q, I just focus in on my P and Q columns. I don't look anywhere else. Okay? So I'm just going to go along the line and figure out what the truth value is, depending on my inputs here. So if P is true and Q is true, I know that true or true is true. And what I'm referencing here is those basic truth tables that we developed with or, well, in this case, inclusive or, right? Exclusive or, implication, and, negation, biconditional, all those truth tables. That's what I'm using here. So I know true or true is true, true or true is true, true or false is true, true or false is true, false or true. Interesting. Does order matter? Did you guys answer that question? False or true is true. False or false is false. False inclusive or false is false. Okay? So now I have P or Q done. Now let's think about the negation of R. Negation is not too crazy, right? We just flip the order, or flip the truth value to the opposite. So if R is true, the negation of R is false. If R is false, the negation of R is true, and so on and so forth. And a lot of times, maybe online or in other computer programming or logic classes you may have taken, you might have seen ones and zeros, and that's okay too. Usually a 1 denotes true, false denotes 0, or 0 denotes false. So that's fine. If you want to use that notation, just make sure you've got it straight and it's clear. So now I've got my hypothesis here. I've got the truth values, and I've got the truth values of my conclusion. So I'm going to go ahead and put together these truth values, thinking about that truth table with the implication. So if I look at that truth table with the implication, it only has 4 rows, right? And don't get these variables mixed up. These P and Q don't have anything to do with that implication truth table that we would reference. So the implication truth table that we'd reference it as P and Q, P implies Q. So true, true, false, false, true, false, true, false. So this is what we're going to be looking at. Just don't worry about the P's and Q's. Focus on true implies true is true. True implies false is false. False implies true is true. False implies false is true. So just focus on those truth value combinations and what the output is. So here we input 2, true, implies false, false. True implies true, true. True implies false, false. True implies true, true. True implies false, false. True implies true, true. False implies false, true. False implies true, true. Okay? So this is the final column. This is what you're looking for when you build your truth table. And now it's maybe not that interesting, but when we're trying to prove logical equivalence and see how different compound propositions are related, it'll be useful to us. But this is just practice now on how to build this truth table and how to break it down. We're going to do another example in the next video, so hopefully this gives you a little sneak peek. And just one question for this video on D2L. I want to know how many rows do I need, depending on the number of atomic propositions that I have. So remember, if I had 2 atomic propositions, it's like P and Q, usually what we dealt with, then I had 4 rows. I had 4 truth value combinations. When I went up to, here, let me write this down. So when I had 2 atomic propositions, I had 4 truth value combinations. Combos. When I had 3, I had 8. So I want to know, what happens if I have 4? What happens if I have 5? What happens if I have some positive integer n? Oh, we'll get to use this notation. N is an element of the integers. Okay, we'll get to see that soon. All right, positive integers. Okay. So answer that question, come back, and we'll do another truth table together.